Hello students, in this session we'll see how the aggregate blending will be done using Rothfuchs method. The first and foremost steps in the bituminous mix design includes the gradation of the aggregates. Aggregates has to be procured from the nearest quarry and we have to check the gradation of material obtained by the nearest quarries. If the gradation of the aggregates doesn't fulfill the specification as suggested by the MORTH specification, then we have to go for aggregate blending. Aggregate blending can be done using the various method in which includes the graphical method, or we can make use of trial and error method. Some of the graphical method includes rectangular chart method, triangular chart method and Rothfuchs method of the aggregate gradation. Under the module 1, we have already discussed how aggregate gradation will be done using the rectangular chart method and the triangular chart method. In this module, we'll discuss how the aggregate blending will be done using Rothfuchs method of aggregate gradation. Step-by-step procedure of aggregate blending using the Rothfuchs method, and then we'll further, after the aggregate blending is done, we'll look into how the bituminous mix design will be done. So I'm going to say that the 100. So we'll discuss. First, we'll understand these what the aggregate gradations are required. The aggregates that are used in the bituminous mixes are categorized into two grades under MORTH specification. We'll see that the grade 1 and the grade 2. In the grade 1, you can see the maximum size of aggregates used are 12.5 mm, whereas in the grade 2, the maximum aggregate size used is the 20 mm. Depending upon the type of the bituminous mix you are preparing, we can choose the required gradation. Now what we have to do is the material procured from the quarry has to be checked for the gradation, and we have to compare whether the given aggregate fulfill the requirement as per the MORTH specification. If the aggregate doesn't fulfill these requirements, then the blending has to be done. So what does it indicate? Let us understand. We have procured the different type of material: aggregate type 1, aggregate type 2 and aggregate type 3. Let us say aggregate 1 is 20 mm down, aggregate 2 is 16 mm down, aggregate 3 is 12.5 mm down, or we'll say 10 mm down. So these are the three materials that we generally get from the quarry. So now what we have to do is all these three material has to be mixed in some proportion, such that when you mix these aggregates in the proportion of selected proportion, you should obtain the aggregate gradation specified by the MORTH specification. Now here, when we do the aggregate blending using the any of the blending method, we will be determining what is the proportion of various aggregate, like how much aggregate 1, what should be the percentage that we have to use. Let us say aggregate 1 we are using X percentage, aggregate 2 as Y percentage, aggregate 3 as some Z percentage. When you add all these things, you should get 100%. So I'm going to say that when we mix the various aggregates in some proportion, we should obtain the gradation specified by the MORTH. Okay. So the other two graphical methods are already discussed. Now gradation. For example, now let us say I'll comparing with the grade 1. For the grade 1, so 100% passing will be correspond to 12.5 mm on the grade which we are choosing. Let us say we are doing it for the grade 2. In the grade 2, the 100% passing will corresponds to 20 mm. Next, similarly take the next one, 80 to 100. Here when we have the upper and lower limit, what we have to do is we have to take the average of it. So average of these two will become 90. So we have to check for the 90% passing on the graph is corresponds to 12.5 mm. Previous chart, we have the 90% pass. The 90% pass corresponds to 12.8. The stable 90% passing corresponds to 12.5 mm C. Similarly, when you check the next size, we will have 55, 75. So the average of it will be 65%. 65% corresponds to, I'm sorry, there's a mistake. It is correspond to 10.75 mm. Explain you the step-by-step procedure of how aggregate blending will be done using the Rothfuchs method. So for the method, first we have to take a graphical graph in which the x-axis represents the sieve size. So this is similar to how we do the sieve analysis graph. Take sieve size in mm on x-axis, and the y-axis represent percentage passing of material through various sieve size. So generally we can plot this on the normal graph sheet only. So on the x-axis, y-axis, the percentage passing will be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and up to the 100% passing that need to be marked on the y-axis. So after marking this, we'll complete this. Usually when we take the scale, we have to take 15 centimeter on x-axis and the 10 centimeter line on the y-axis. Now, after marking the percentage passing on the y-axis, it is required for us to fix up sieve size points on the x-axis. For that will be the points which to be marked on the x-axis, the sieve size, that will be. So if I plot this, the 100% passing will be this. If I take 100% passing line, the last point will be the 100% passing corresponding to that. The sieve size will be 20 mm. Mark that point. So now before marking the 90% passing, I forgot to mention, we have to mark the desired gradation line. So desired gradation line will be plotted such that the 0% pass on your x-axis and the 100% pass, you have to draw one line, inclined line. This will represent the desired gradation. Okay, so now 100% passing on the desired gradation line will corresponding to 20 mm C. The next is we have checked the 90% pass mm C that need to be marked here. So how do? You take 90% will be here. Just draw one light line, okay, such that the 90% will meet on the desired gradation line, and drop that line down. Clear? So this will meet the at x-axis at some point. This will represent the size 12.5 C. Mark that point here. The 65% will come here. Okay, draw one light line from 65%. Drop it down. So this will mark the 10.74 mm C. Similar to this, the percentage corresponding to the percentage passing, we have to plot the sieve size on the x-axis. Once this is ready, the next step is to plot the grain size distribution size curve for the various aggregates. Let us say we have aggregates of aggregate A, aggregate B and aggregate C that does need to be blended to get the required gradation. So first what we have to do is plot the grain size distribution curve for these three aggregates, aggregate A, aggregate B and aggregate C. In the next step, what we have to do is to draw the balancing line. So we have considered the gradation line has been drawn for the various aggregate A, B, C. The next step is to draw the balancing line. So you draw the balancing line such that it represents the area above the line, it will be equal to area below the line. So now you can see here I am drawing the balancing line for the three aggregates A, B, C, D. Once you draw the balancing line, what you have to do is join 0% passing of one balancing line with the 100% passing of other balancing line. So see, like this, we have to join the 0% passing of a balancing line with the 100% passing of the balancing line. So these lines will meet the desired gradation line at some point. Okay, so check this, and that draw a horizontal line parallel to the x-axis from those points. So now you can see that these will meet the percentage passing line at some point. So here, from here to here, the percentage passing will be, you can see from here to here, I'll say take it as it will be around we'll say 40, this will be the 50%, so 50%. So it indicates that we have to get the required gradation, we have to mix 50% of aggregate A and aggregate C has to be taken in the proportion. So if you check this particular point, almost 70% will be aggregate C and the remaining proportion will be aggregate B. The remaining 30% will be aggregate B. So now it says that to get the required gradation as per the recommendation, we have to blend aggregate 50% of aggregate A and 30% of aggregate B, and the remaining 70% will be the aggregate C. Let's take an example and see how aggregate gradation will be done using the Rothfuchs method. So they have given the data that the three aggregates has to be blended, aggregate A, aggregate B and the aggregate C has to be blended to get the required gradation as per the specification. Now once the specification is given, find out what is the mid gradation. Mid gradation will be the average of 3 and they have given percentage passing of various material. Now we have to find out what would be the proportion of aggregate A, aggregate B and aggregate C has to be considered to get the required gradation. That will be depend upon the percentage passing. So now the 100% passing of the mid is there for 19 mm. This is the next size. Next size will be the 85% passing is there for 12 sieve size. If I consider 55% the graph, so you can see here the graph. So this is a desired gradation line. So 100% desired gradation line corresponds to 19 mm or 20 mm sieve, and corresponding to that the various sieve size will be marked depending upon the percentage passing on the x-axis. Now if you look at the graph, in the first step what we will do, draw the line 10 centimeter line on the y-axis, 15 centimeter on the x-axis, form a rectangle, draw the line passing 0% to 100% page passing with inclined line that will represents the desired gradation line. So after it is ready, what we have to do is we have to plot the sieve size. So look, is plotted here. So we will see that 100% and 97% corresponding to that will have 19 mm. Sieve size, that is 12%. If you see here 78% which go up to the meet this point and drop it down, it will have for the 12.5 mm. Similarly, plot the sieve size, and once the sieve size is ready, in the next step find out the draw the aggregate gradation line. First step, what we have to do is draw an x-axis for about 15 centimeter, y-axis take 10 centimeter. Mark percentage passing on y-axis, that will be the first step. Once it is ready, then what we have to do is you draw a inclined line from 0% pass of smallest size to the 100% pass of the largest line. Draw a inclined line of suitable slope which will represent the specific line or specification line or desired gradation line. After drawing the desired gradation line, we have to mark the percentage or sieve size on the x-axis. So if you see here, the 100% passing, if you consider the 100% passing will be there for 19 mm 5. So 80%, if you look here, 80% is there for the 12.5 mmc. Similarly, 55 percentage, if I somewhere here it will come, 55 percentage will corresponds to 4.75. So similar to that, you draw the sieve size corresponding to the percentage passing. After fixing the sieve size on x-axis, the next step is to draw the aggregate gradation line for the various aggregate A, B and C. Now you can see here, this is the line, the gradation line obtained for aggregate A. The gradation line obtained for aggregate B is this one, which is in the red color, and the other one is for the aggregate C. Okay, so after drawing the gradation line, we have to draw the balancing line which are there on the dotted lines. Okay, so when you draw the balancing line, ensure that area above the balancing line and area below the balancing line will be equal. So I mean to say that if you consider here, this will be the area below the above the balancing line, and this is the area below the balancing line. So you have to draw an average line such that these two areas will be approximately equal. Similarly, draw the balancing line for aggregate B and aggregate C. So this dotted line in the green represents the balancing line. After drawing the balancing line, join 100% of the one balancing line with the 0% balancing line. So this is how you need to draw that. So it's seen that. So this dotted line indicates that 100% passing of one balancing line to the 0% balancing line for the other line. So you can see that these lines have met the desired gradation line at some point. Draw a horizontal line which is parallel to the x-axis to meet the percentage passing line. So now you have got that the first line between the distance between the first line is 0.07, that is 7%. The second is around 30%, 10, 20, 30, and remaining 63% for the other material. So that means to say that to get the required gradation, you have to take aggregate C of 7%, aggregate B of 10%, and aggregate A for 63%. So now how you will consider? So whichever the first line comes here on the graph, that would be the first proportion. So here you can see the first proportion will be the aggregate C, that will be the first division will corresponding to the aggregate C. By any chance, if you have got a gradation for aggregate A line here, this would be the percentage passing for aggregate A. See, you can see here, whichever the line comes first here, that would be the first aggregate here. The second line is aggregate B, so the second percent what we have obtained is for aggregate B, and third line here is for aggregate A, and that is what is being represented here. So now to get the required proportion, we have to blend aggregate A, aggregate B, aggregate C in the ratio 63%, 30% and 7% respectively. After aggregate gradation is done, the next step is to do the bituminous mix design using the Marshall method. With this I'll conclude. We'll discuss Marshall mix design in the next class. Thank you.